Hi, welcome to Math for All. In this lesson, we're going to look at how we can simplify algebraic expressions. Okay, so we'll start with something simple. Whenever we encounter different letters and numbers, the first thing to remember is that we need to group them together according to like terms. Okay, so we're going to take everything that's similar and we'll put it together. It's almost the same as looking at different fruits and vegetables. So for example, if we wanted to find out how many potatoes, apples, and maybe oranges that we have, we can't really say that we have 3 potatoes and 5 apples and say we have 8 of oranges, right? We have to look at specific fruits and vegetables and count them likewise. Same with letters. We're going to do the same thing. We're going to count letters like x's. How many x's do we have? How many y's do we have? And how many numbers do we get in the end? And so the first thing I'm going to do is I'm going to look at our x's. So 18x, I'm going to put negative 10. So the negative travels, so the sign in front of a number travels together with the letter. And that's all we have for x's. We also have this expression for y and this expression for y as well. So I'm going to say plus 2y, and the negative will travel with the y. Okay, and then the 4 will combine with the 6. Okay, what do we get? If we have 18 x's and then we take away 10 x's, we're left with 8 x's. Similarly with the y's, 2y minus y gives us 1y. Whenever we have a letter, we automatically assume that there's a 1 in front of it. So all we have to do is just write down the letter. If you write down the 1 in front, it's not really incorrect. It's the same thing. And with numbers, 4 plus 6 gives us 10, and this will be your final answer. Okay, if you take a look at our next example, it's very similar to what we did in our previous lesson, where we had to deal with brackets, except in the previous lesson we had to multiply a huge bracket by another bracket. In this case, if we have a number in front of a bracket, we need to remember to do the same thing, that whatever the number is, it has the following effect on this bracket. I'm going to choose something simpler because this number is positive. I'm going to show you that the 2 in front of a bracket really tells us that we have 2 of these brackets. So we have essentially what this is x minus 2 and x minus 2 again added together. So if we were to add these two together, we would get 2x and then negative 2 plus a negative 2 will give us an even more negative number of negative 4. So we have 2 of these, and again, it's just representing it in this form. Let me erase this and we'll take a look at the entire question. So all we have to do really is take the number that we have in front of a bracket and show that it has this effect on the rest of the bracket. We are going to multiply the sign between the number and the bracket is multiplication. We're going to multiply this number by every single number inside the bracket. Negative 3. So negative times negative once again gives us a positive answer. So we're going to get 6x. So number has an effect on the number. Negative 3 times negative 5 is positive 15. Plus 10 stays all by itself. And then once again we have to have a doubling effect on this bracket, where this 2 multiplies by everything within that bracket. So 2 times x gives us 2 x's, and 2 times negative 2 is negative 4. On to our final step, we just need to combine like terms. So we have x's and we have our numbers. So I like to think of x's as being one entity. That's why we need to combine them into a single group. So 6x plus 10x plus 2x, and then the numbers will follow. So we'll have 15 and minus 4. Okay, so on to our final answer. When we combine all these x's, we're going to get 18x, and then 15 minus 4 gives us 11, and that's our final answer. Okay, why don't we take a look at our final example. In this example, the reason I like this example is because we have quite a few negatives in front of a bracket. Whenever you see a negative, I want you to keep in mind that there is an invisible number in front of it, in front of the bracket. And that number happens to be the number 1. We can either write it in or we can leave it blank. Okay, sometimes it's helpful to have a number in front of a bracket because we know that if there's a number in front of a bracket, you're really multiplying the entire bracket by the number in front of it. Okay? Or we can, why don't we do the first part without a number in front and the second part with the number -1 in front of it. Okay, so our goal is to kind of simplify what's inside the bracket. In this case we can't because we have a squared and we have a, so these are different entities. We cannot really combine them together. If we had a squared and a squared, we would be able to. In this case we cannot. So the first thing we're going to do is we're going to take the bracket and we're going to try and open it up. So the 5 stays as is. What the negative does is that it actually will change all the signs within the bracket. If it was positive, it will become negative. If you had a negative sign inside a bracket, it will become positive. Reason being is because you're multiplying everything inside the bracket by this negative sign. And so negative times positive gives us a negative answer. Negative times positive gives us a negative answer. Moving on to the next question. With the -1, we can clearly see that we're multiplying -1 by positive 3a. We're going to get negative 3a, negative a squared, and a positive 10. It's positive because, again, the signs, whenever you're multiplying signs that are the same, you will get a positive answer. For our final step, we need to combine like terms together. So we see a squares, a's, and the numbers all in different places. So all we need to do is now just place them together. It doesn't really matter what the order is. Mathematically speaking, most of the time you want to have square numbers first, and then letters that are not squared, followed by a number. It will make more sense once we start talking about parabolas in a greater depth. So let's take a look. We have negative 2a squared minus a squared minus 3a minus 3a plus 5 and plus 10. Okay, for a final answer, negative 2a minus a makes it even more negative. So it's the same as negative 2a minus 1a, which gives us negative 3a squared. Negative 3a minus 3a makes it more negative, gives us negative 6a. And 5 and 10 gives us 15. Okay, before we stop, let's just address the negative numbers, because I understand most of the time the confusion is when you take a number that's negative, so for example negative 2, and you're subtracting another number from it, such as number 5. The example I like to use is a building analogy. So if you live in a building, if you go down 2 floors from the ground floor, you're on the negative 2nd floor, so you're in the underground parking lot. If it was such a thing, if you could go down another 5 floors, you'd be on the negative 7th floor. So that's probably one of the best ways to remember how to deal with numbers when you are subtracting from a negative number. Okay? So in this case, our answer will be negative 7. One more example. If you are on a negative 3rd floor and you're going down 2 more floors, you're going to be on the negative 5th floor. If I was to add instead, let's say you're on the negative 5th floor and we're going up 7 floors, we're going to be on the 2nd floor. By the way, with math, it's very simple to just switch numbers around as well. When you're adding or subtracting, you can switch them. And so it's the same as saying 7 minus 5, and you'll still get the same answer. Okay, so lastly, I'd like to talk to you about taking what we've learned and actually applying it to real life. So this is a very basic example. If we had a rectangular shape, let's say if it was the size of a swimming pool, or if it was the an expression for an area of land, like a backyard. And so if you have a length that's expressed in this form and you have a width that's expressed in this form, the question is, what would you be able to write an algebraic expression for the area of a rectangle? And so we have to keep in mind that the equation for the area of a rectangle is area equals length times width. Our length is here, this is our width. All we have to do is plug in the numbers. What do? We write this again, except instead of length, we're going to put 3x plus 4. I like to put brackets around it because we're going to multiply it by our width. And so when we do, if we had no brackets, we'd only be multiplying by the number 4. The brackets tell us that we're actually multiplying by, we're multiplying this by everything inside the bracket. So we'll take this number again and we'll apply it to our first number and the second number, whereby we're multiplying it. So 3x times 2x, the numbers multiply and the x's multiply. The numbers, 3 times 2 gives us 6. X times x will give us x squared. Whenever we multiply a number or a letter by itself, we can express it in this form. It's shorthand notation. 4 times 2x gives us 8x. And this is our expression for the area of the swimming pool. Now, if I was to say that x represents a number and the number is 2, the question is, what would be the exact area of this swimming pool if it was a swimming pool? All we have to do now is take our number 2, and plug it in for x. So we can write this again in this form: 6 times 2 squared plus 8 times 2. What do we get? We get 6 times 4 plus 8 times 2, which is 16. 6 times 4 is 24. 24 plus 16 is 40. And that's our answer. Whatever the units are, if 2 is centimeters, and I'm guessing our final answer will be centimeters squared for the area. Okay? Thank you very much for watching.